Hello and welcome to the video on decision tree algorithm in machine learning. So, decision tree is a supervised learning technique that can be used for both classification and regression problems, but mostly we use decision tree to solve the classification problems. So, it is a tree structured classifier where internal nodes represent the features of the dataset, branches represent the decision rules, and each leaf node represents the outcome. So in a decision tree, there are two nodes, which are the decision node and the leaf node. Decision nodes are used to make any decision and have multiple branches, whereas leaf nodes are the output of those decisions and do not contain any further branch. So the decision or the tests are performed on the basis of features that are given in the dataset. So it is a graphical representation for getting all possible solutions to a problem based on the given conditions. We call it decision tree because the structure is similar to a tree and it starts with a root node which expands on further branches and constructs like a tree. So in order to build a decision tree, we use the CART algorithm, which stands for classification and regression tree algorithm. As already discussed, we can perform both classification and regression tasks with this algorithm, hence the name CART. So a decision tree simply asks a question based on the answer yes or no, and it will split the tree into next subtree structure. So by seeing this image you will get more clarity. This is the decision node or the root node. Now based on a certain if else condition, we will split this decision node into two subtrees. So this is one is entire subtree and this is another entire subtree. Now these all leaf nodes are having the decisions made by all these subtree structures. So why do we use decision trees? There are various algorithms in machine learning. So we choose the best algorithm for the given dataset. The main point to remember is that decision tree they usually mimic human thinking ability while making a decision, so it is easy to understand. Now the logic behind decision tree can be easily understood because it's just a tree like structure, so we can easily derive back the logic based on which the decision was made or the prediction or the classification was made. Now few important terminologies before moving on to the decision tree working. So root node is from where the decision tree starts. So the first or the top node is known as the root node. It represents the entire dataset, which further gets divided into two or more homogeneous datasets. So once we make two or three splits on the root node, then the entire dataset is divided into two or three subtree structures. Now leaf node is the final output node, and tree cannot be segregated further after reaching to a leaf node. Splitting is the process of dividing the decision node or the root node into subnodes according to the given conditions. Here we want to see this term called branch or a subtree. So a tree that is performed as splitting the tree. So this is a subtree that we are getting. Pruning is the process of removing unwanted branches from the tree. This is very similar to the gardening term that we use, pruning. Parent and child node. The root node of the tree is called the parent node and other nodes are called the child nodes. Now have a look at this picture and we'll try to solve the example. So suppose there is a candidate who has a job offer and wants to decide whether he should accept the offer or not. This is our main problem statement. Now to solve this problem, the decision tree starts with the root node salary attribute. So salary will be considered as the root node as the parameter of making the decision. So the root node splits further into next decision node, that is distance from the office, whether office is located close to home or not, and one leaf node based on corresponding labels. The next decision node further gets split into one decision node cap facility. This is another factor, and one leaf node. Finally, the decision node splits into two leaf nodes accept the offers and decline the offer. So here on as we are taking salary is between 50,000 to 80,000. This is the root node. If yes, then we'll think further about the location of the office. If the salary is less than $50,000, then straight away we'll reject or decline the offer. So no further questioning, we cannot accept that offer. But if the salary ranges between 50,000 to 80,000, then this path will be taken and the next question will be asked whether the office is near to home or not. Again, if the office is not near to home, declined. So this is another decision, offer declined. But if the office is close to home, then we'll ask the next question. Does the office provides cab facility? If yes, then we'll finally accept the offer. So to accept the offer, we have to take this part and all the conditions should be satisfied. Otherwise, on the other side of the tree, that we can straight away decline the offer. Now, finally, let us understand some of the disadvantages of using a decision tree. So the decision tree contains a lot of layers, which makes it slightly complex. Sometimes checking too many conditions, it becomes a little complex. Now, this may also lead to an overfitting issue, which can be resolved by using the random forest algorithm. This is another very important and very super powerful machine learning algorithm that we are going to cover in the next few videos. For more class labels, the computational complexity again of the decision tree may increase. So these were some of the disadvantages of decision tree. I hope you are clear with the basic concept and working of decision tree. Now let's move to the Jupyter notebook and try to implement the decision tree algorithm in sklearn. Hello, and welcome to the practical implementation of decision tree. So let us start. Import pandas as pd, import numpy as np. Now I'll create one data frame and we'll use the user data.csv that we were seeing in the videos of logistic regression and other classification algorithms. So df is equal to pd dot read underscore csv, and we have user underscore data dot csv. So let's check our df. So this is the dataset that we are working with. Now we'll extract the dependent and independent features. So what I'll do, x will be df of I'll use gender and let's say age, and the third one is estimated salary, and y will be df of purchased. So this we have separated our dependent and independent features. Now let's import from sklearn dot model underscore selection, import train test split. Now I'll make x train, x test, y train and y test. So x train, x test, y train, and then I have y test. This will be train underscore test, and then split. Here I will give x and y, and my test underscore size will be of let's say 20%. So this I have separated my x train and x test. Now we'll import the decision tree classifier. So from sklearn dot tree import decision tree classifier. Then I'll make one instance for the classifier, that is CLF, and decision tree classifier. So the CLF is trained. Let me mention the criteria that we want to use, that is the entropy. So criterion, that will be entropy. So again I have a train classifier. Oh, I have my instance ready. Now let's train this. So CLF dot fit method, and I'll train it with x train, and I have y train. So this is training. Okay, could not convert string to float. Okay, we have this we are using the gender attribute, that is a categorical variable, and so we are not going to perform the feature encoding. So as of now, let's remove the gender attribute and work with the remaining two. So now this classifier is ready. Now what we'll do, let's make some predictions. So y underscore pred will be CLF dot predict, and we want to predict on x test. So these are all our predictions. Now let's see what do we have inside y pred. So all 10 10 10 the predictions that we have. Now let's import from sklearn dot matrix import accuracy score. So we'll try to find the accuracy of our model. So accuracy underscore score. Now what we'll do, accuracy score, this will be y-test and y-pred. So we are getting a very good accuracy of 87.5%, which is actually a really good accuracy for a machine learning model. So this was the practical implementation of decision tree. We use the user dataset to predict whether the customer will purchase the item or not based on the gender, age and estimated salary, and we are getting accuracy of 87.5%. So I hope you are clear with how decision tree works. Now let's move to the next video. Thank you.